Welcome to DevOps Academy. Today, let's talk about version control system. A version control system, VCS, is a tool that helps manage changes to files over time. It allows multiple developers to work on a project simultaneously without overwriting each other's work. VCS tracks revisions and history, enabling users to revert to previous versions if needed. Popular examples include Git, Subversion SVN, and Mercurial. One central repository. All code lives in a single server, which everyone connects to. Working copies. Each developer downloads, checks out the code to their own machine. Commit and update. Developers make changes locally, then send them back, commit, to the central repository. Others can then update their working copies to get the latest changes, pros and cons easy to understand and manage. Good for small teams. If the central server goes down, no one can commit or update. Collaboration depends heavily on that single point of truth. In this module, we'll explore the essential topics that form the backbone of Git and version control. We'll start with what Git is and how its workflow operates. Then, we'll compare different types of version control systems and dive into basic Git commands. You'll learn how to branch effectively, provision code, fix issues in the main branch, and deploy code using Git. By the end, you'll be equipped to manage code collaboratively and confidently in real-world projects. Let's talk about Git, a powerful tool for source code management. Git is free, open source, and designed to handle projects of any size. It tracks changes in your code and enables multiple developers to collaborate efficiently, even on complex, non-linear workflows. Key features include fast performance, distributed architecture, reliable data assurance, and a staging area for clean commits. Git also supports branching and merging, making teamwork seamless. And with Git, you can automate deployments and integrate CI/CD pipelines with ease. Let's dive into the workflow diagram to see how developers interact with the repository and collaborate through branches. Let's break down the Git workflow. At the core of Git is the repository, a collection of source code. The workflow moves through four key areas: the working directory, where you make changes; the staging area, where you prepare those changes; the local repository, which stores committed versions; and the remote repository, where code is shared with others. You'll use commands like git add to stage changes, git commit to save them locally, and git push to send them to the remote repo. To bring in updates, use git fetch or git pull. And when collaborating, Git merge helps combine changes across branches. Understanding this flow is essential for smooth collaboration and version control. Types of version control system: local version control systems, centralized version control systems, distributed version control systems, local version control systems. Think of this as a VCS, but without a remote repo. You manage and version all the files only within your local system. There is no remote server in this scenario. All the changes are recorded in a local database. As we can see in the image below, every developer has their own computers and are not sharing anything. Centralized version control systems. Here, there's a central repo shared with all the developers, and everyone gets their own working copy. Whenever you commit, the changes get reflected directly in the repo. Unlike distributed systems, developers directly commit to the remote, which means they may affect files knowingly or unknowingly. Distributed version control systems. In distributed systems, there is a local copy of the repo for every developer on their computers. They can make whatever changes they want and commit without affecting the remote repo. They first commit in their local repo and then push the changes to the remote repo. This is the type used majorly today. In the centralized VCS, every commit was directly to the, say, remote repo. But in distributed VCS, it first happens in the developer's local repo, and then they send those changes to the remote. A remote repo is a JIT repo on a server, hosted by any such providers like GitHub, Bitbucket, etc. When you commit changes in a centralized system, the changes are directly visible to others as you commit directly to the remote. But in distributed, you first commit locally, and it will not allow others to see until you push it to the remote. Likewise, when others commit a change in a centralized system, you can directly see them, but you need to pull changes in the local repo in distributed systems after they push them. So, distributed systems can also be beneficial in having only necessary updated completed code with everyone, rather than having even experimental code like in centralized systems. System failures. In a local VCS, say, if your hard disk gets corrupted or you lose the file, you lose everything related to it, including all the changes. Similarly, in the centralized VCS, if you lose the repo, everything is just gone. But in a distributed VCS, even if someone's local repo is corrupted, or the remote doesn't work, or is deleted, or anything happens, there is a copy available with other developers. So you can take it from them, push to remote, and everything is back on track, just like before. There is no problem of single-point failure in distributed VCS. You always have your code safe with fellow developers. Before using Git, it's important to configure your identity. This ensures your commits are properly credited. Use git config, global username to set your name, and git config, global user email to link your email to your commit history. Finally, enable command line coloring with git config, global color UI auto. This makes reviewing changes easier and more intuitive. These setup steps apply across all your local repositories. Let's begin with Git setup and initialization. First, configure your identity using git config. This sets your name and email for commit history. Then, to start tracking a project, use git init to turn any folder into a Git repository. If you're working with an existing project, use git clone URL to copy the entire repository from a remote source. These commands lay the foundation for version control and collaboration. Let's walk through Git's staging and snapshot process. Use Git status to check which files have been modified. To stage changes, run git add. If you change your mind, Git reset will unstage it without deleting your edits. Want to see what's changed? Use git diff for unstaged changes and git diff stage for staged ones. Finally, commit your snapshot with git commit-im your message. This saves your progress in the local repository. In Git, branching lets you isolate your work. Use git branch to list all branches. An asterisk marks the active one. To create a new branch, run git branch name. Switch between branches using git checkout. When you're ready to combine changes, use git merge branch to integrate another branch's history into the current one. And with git log, you can review all commits in your branch's timeline. How to inspect and compare changes in Git. Use git log to view your branch's commit history. To compare branches, git log branch A and B shows what's unique in branch A. If you want to track changes to a specific file, even across renames, use git log follow file. For differences between branches, git diff branch B and A highlights what's changed. And with git show sha, you can inspect any Git object in a readable format. In Git, tracking path changes is essential for managing file movements and deletions. Use git rm file to remove a file and stage that change. To rename or move a file, use git mv old path, new path. For a detailed view of path changes, git log stat m shows commit logs with movement indicators. Now let's talk about rewriting history. Git rebase branch reapplies your commits on top of another branch, great for cleaner histories. And git reset hard commit resets your working directory and staging area to a specific commit, discarding changes. In Git, you can prevent accidental commits by setting global ignore patterns using git config, global core.excludes file. This keeps clutter out of your version history. For temporary changes, Git offers stash commands. Use git stash to save your work, switch branches safely, and return later. Git stash list shows your saved changes. Git stash pop restores the latest stash, and git stash drop discards it when no longer needed. These tools help you stay flexible while coding. In Section 3, we focus on provisioning code, getting your project set up and ready to work. Start by cloning the repository from Bitbucket using the provided URL. If you're using Visual Studio, install the Git integration tools to streamline your workflow. Then, dive into the lab activity to practice provisioning code hands-on. This step sets the foundation for collaboration and deployment. Let's walk through a practical Git workflow. First, create a repository and clone it to your local system. Add some files, like HTML or text, and push them using HTTP. Then, configure SSH access and switch Git from HTTP to SSH. Update your files and push changes via SSH. Next, create a new branch, add more code, and push it to that branch. Finally, merge your branch into the main branch to complete the workflow. This sequence builds real-world Git proficiency step by step. In modern development, collaboration is key. Teams thrive when they use branching, merging, and pull requests effectively. Clear communication and version control best practices help avoid confusion. Automation boosts efficiency, while code reviews ensure quality. Continuous learning keeps teams sharp, and regular monitoring and refactoring help maintain clean, scalable code. These habits drive productivity and elevate team performance. Let's explore Git branching. The master branch is your production-ready code. Before code reaches master, it's integrated and tested in the develop branch. New features are built in feature branches, which branch off from develop and merge back when complete. When preparing for release, use a release branch for final testing. And for urgent fixes, hotfix branches go straight to master, then back to develop to keep everything in sync. This structure keeps your workflow clean, organized, and ready for collaboration. Let's look under the hood of Git. First, we have blobs, binary large objects. Each file version is stored as a blob, named by its SHA-1 hash, and contains only the file's content, not metadata. Next, trees represent directories. They link blobs and other trees, forming the structure of your project. Like blobs, trees are also identified by SHA-1 hashes. Finally, commits capture the state of your repository. Each commit points to its parent, forming a history chain. If a commit has multiple parents, it's the result of a merge. Together, blobs, trees, and commits form Git's powerful versioning engine. In Git, branches let you create separate lines of development. You typically branch off to build a feature, then merge it back into master once complete. Each branch is tracked by head, which updates with every commit. Tags are like bookmarks for specific versions. Unlike branches, tags are immutable, perfect for marking release points in your project. And with Clone, you copy an entire repository to your local system. It mirrors everything, so you can work offline and sync changes later. This is how collaboration begins. Let's review some essential Git concepts. The pull command brings changes from a remote repository to your local one. Great for staying in sync. Push sends your local changes back to the remote, making them permanent. Head is a pointer to the latest commit in your branch, constantly updated as you work. Each commit is a revision, uniquely identified by a SHA-1 hash. And finally, the URL defines your repository's location and is stored in Git's config file. These basics are key to navigating any Git workflow. Let's walk through the Git lifecycle. You begin by cloning a repository. This gives you a working copy. You modify files locally, and if needed, pull updates from teammates. Before committing, review your changes carefully. Once ready, commit and push your updates to the remote repository. If you spot an issue after committing, you can fix it and push again. This cycle ensures smooth collaboration and clean version control. Let's walk through the Git workflow. Start by cloning the central repository to create your local working copy. Make edits, add, move, or modify files. Use Git status and Git diff to review your changes. When ready, commit with a clear message. Push your changes to the central repository. If you need to fix something, amend the commit and push again. And don't forget to pull updates regularly to stay in sync with your team. This cycle keeps your codebase clean, collaborative, and versioned. Git supports two types of tags, lightweight and annotated. A lightweight tag is simply a pointer to a specific commit, like a branch that doesn't move. An annotated tag, however, is a full Git object. It includes metadata like the tagger's name, email, date, and a message. It can even be signed with GPG for verification. To create one, use git tag-av 1.4-m, my version 1.4. Annotated tags are ideal for marking release versions with a traceable history. Let's talk about lightweight tags in Git. These tags are simple pointers to specific commits. Unlike annotated tags, they don't store extra metadata, just the commit checksum. To create one, use git tag name without any options like -a, -s, or -m. For example, git tag v 1.4-lw creates a lightweight tag. When you run git show on it, you'll only see the commit details, not tag-specific info. Lightweight tags are great for quick, temporary version markers. Sometimes we forget to tag a commit. No problem. Git lets you tag commits retroactively. First, use git log, pretty online, to find the commit's SHA1 hash. Then run git tag a, tag name, commit hash, to assign a tag to that specific commit. For example, git tag a v1.296d52 a2 tags the commit with version 1.2. This helps you organize your history even after the fact. By default, Git doesn't push tags to remote repositories. To share a tag, use git push origin. This sends the tag to your remote server, just like pushing a branch. For example, git push origin v1.5 makes the tag available to your team. To delete a tag locally, use git tag da. This removes the tag from your local repository. But remember, if it's already pushed, you'll need to delete it remotely too. Let's learn how to delete git tags. To remove a tag locally, use git tag d. For example, git tag dv 1.4-lw deletes it from your local repo. But this doesn't affect the remote. To delete a tag remotely, you have two options. Use git push origin, refs tags, xiao, or the simpler git push origin delete. Both commands remove the tag from the remote repository. When you want to view the state of your project at a specific tag, use git checkout. This puts your repository in a detached head state, meaning you're not on a branch. You can still explore or test, but commits won't be saved to a branch unless you create one. To do that, use git switch-c, and if you want to undo the checkout, just run git switch-. This gives you flexibility while keeping your history clean. Let's deploy code using Git on a LAMP stack. First, set up your LAMP environment on a VM or server. Then, install Git on that same machine. Clone the repository using the provided Bitbucket URL. Pull the latest code to ensure you're up to date. Next, configure the code so it's accessible via a browser. This might involve setting file permissions or updating Apache settings. Finally, test your deployment in any browser to confirm everything works. Let's explore 3 powerful branching strategies. Trunk-based development keeps things simple. Developers commit small, frequent changes directly to the main branch, backed by automated tests. GitHub Flow is lightweight. Create a branch, commit, open a pull request, merge, and deploy quickly. And for larger teams, GitFlow offers structure with dedicated branches for features, releases, and hotfixes. Choose the strategy that fits your team's size, speed, and complexity. Let's level up your Git workflow with best practices. Start with clear branch naming. Use formats like feature/login-page or hotfix/security-patch to keep things organized. Always merge through pull requests to ensure peer review and protect your main branch. Integrate Git with CI/CD pipelines. Run automated tests on every pull request and deploy only after successful builds. Use feature flags to avoid blocking releases. And finally, foster collaboration. Commit often, document your Git policy, and enforce standards with hooks or CI rules. These habits build reliable, scalable teams. Let's practice 2 popular Git workflows. First, GitHub Flow. Create a new repository, clone it locally, and start a feature branch. Add a greeting file, commit, and push. Then, open a pull request and merge it into main, simple and fast. Next, trunk-based development. Clone an existing repo and work directly on the main branch. Make small, frequent commits like updating the readme or adding a .gitignore. Use clear commit messages like docupdate or chore add ignore rules. Push and observe how CI/CD responds instantly. These exercises build real-world confidence. Let's walk through a Git flow exercise. Start by creating a repository with 2 branches. main, and develop. From develop, create a feature branch, say feature login. Add a login.html file, commit, and merge it back. Then, create a release branch like release-v10, merge it into main, and tag it v10. To simulate a bug fix, create a hotfix typo fix branch from main. This structured flow helps teams manage features, releases, and urgent fixes with clarity. Let's master Git Flow, a structured workflow for teams. Start by creating a repository with main and develop branches. From develop, spin off a feature branch like feature login, add your code, commit, and merge it back. Then create a release branch, say release v10, merge it into main, and tag it v10. For urgent fixes, create a hotfix typo fix branch from main. These steps keep your codebase clean and your team aligned. Bonus challenge: visualize your branching history, set up GitHub Actions to auto-test pull requests, and reflect on which strategy felt most organized. Git Cherry Pick lets you apply a specific commit from one branch onto another. It's handy when a commit lands on the wrong branch. You can switch to the correct one and cherry pick it over. But use it wisely. Cherry picking can duplicate commits and complicate history. In most cases, merging is preferred. Still, it's a powerful tool when used intentionally. Run git help-a to explore more Git commands and sharpen your workflow. Cherry picking lets you apply a specific commit from one branch to another using its hash. It's useful when a commit lands in the wrong place, but use it sparingly. Overusing cherry pick can duplicate commits and clutter your history. Merging, on the other hand, brings in all changes from one branch while preserving context. To cherry pick, first check out the target branch, then run Git Cherry Pick. You can also edit the message or skip committing with edit or no commit. Know the tool, but choose wisely. For more information, the Git sheet is available. For further information, you can visit our blog and watch the YouTube video, the link to which is available in the description. To fix a broken main branch in Git, here's a short summary of the recovery steps. Back up the current master. Git checkout, be old master. Checkout last stable commit. Git checkout, head. Create a new branch. Git checkout, be new master. Delete local master. Git branch, dmaster. Change default branch in Bitbucket to new master. Delete remote master. Recreate master. Git checkout, be master. Push it, git push origin master. On the concluding note, remember, every step you take towards learning brings you closer to your goals. Stay curious, stay consistent, and never be afraid to challenge yourself. Your hard work today will shape the success of tomorrow. Keep pushing, keep growing, and always believe in your potential. Don't forget to like, subscribe, and hit the notification bell to stay updated with more valuable content. Keep learning and keep shining. Thank you for your attention and never miss a weekly tech episode.